Drilling fluids touch just about everything in the drilling process. We're here to deconstruct the drilling process and drilling fluid concepts to provide a deeper understanding of our industry. In each episode, we'll share information, talk to interesting people, and maybe share a few stories along the way. Welcome to the Flowline, a production of AES Drilling Fluids, brought to you by Matt Offenbacher and Justin Gauthier.
Hey everybody, welcome back to another episode of the Flowline. Here with my lovely co-host, Mr. Matt Offenbacher. Matt, full swing 2025. How's everything been? You've been traveling a little bit. I've been traveling. I feel like it's been a few weeks since we got behind the mic, but nonetheless, how's things going?
I mean, pretty good. It's been fast, but I guess we expected that, right?
Fast and furious.
Fast and furious. But I mean, how about yourself?
Yeah, same thing. Just, a lot of pour over from last year. Nothing groundbreaking. But just again, lots to look forward to. Drilling activity is one of those things. It's kind of like, where are we going from here? And but overall, there's enough work to stay busy, and the pie's big enough for everybody. So all is well.
Yes.
With that being said, a big congratulations to Ricky Toombs. I got to say that. It's obviously gentleman who works under your direction, but we've got another addition to the AES family. How about that?
Yeah, it was in fact a baby. I mean, his wife looked very uncomfortable for a while, so I'm glad she's not going to listen to this, thank goodness. But no, congratulations to the Toombs. So yes, excited for them.
No, most definitely. And for the folks listening to the podcast, many of you have probably met Ricky. So if you're close enough to send him a message, wish him a congratulations. He's off doing dad things, big things. And, again, it's just growing the family. It's great to see that. And, Ricky's a good guy and adds a lot of value. And I'm sure Matt's probably wants him back before he wants to come back. But nonetheless,
I'm already tired of getting forwarded his emails. So yeah, hurry up.
Okay. Oh, that's great. Well, Matt, speaking of drilling, obviously that's why we're here, talk about drilling fluids. A big push, kind of over the last several years now and probably moving forward is just to get any time we can drill with water-based mud and unconventionals. It seems to be a hot topic of discussion. You look at some wells, make sure the criteria fits, and away you go, putting water-based mud in the hole versus oil-based mud. And I think it'd be good to cover, just sort of what that looks like, what type of fluid that actually is, because it can vary. But again, it's just sort of something that is on the front burner most of the times. And I think it'd be good to refresh folks' memories and some considerations and things people need to just really look for when going from a situation where you're going to drill with oil-based mud now saying, oh, let's do this with water-based mud. What do you think?
No, absolutely. I mean, this conversation comes up all the time. So it seems like we could do, 500 episodes on this, and I feel like we'd still have people who are like, tell me more.
Right. Yeah, there's a lot to unpack, but I think we're going to do a great job of getting through most of it. And again, at the end of it, if people have more questions, they want us to dive deeper, we always can. But kind of starting things off, Matt, I think there's always assumptions that need to be made, when considering moving in that direction. So let's talk just sort of over some of the assumptions drilling unconventionals with water-based mud.
Well, I think I just like to put the I don't know what you call it, barriers. There's an exception to everything, right? And so just to understand sort of where the mindset lies is unconventional reservoir. And I mean, we've published a paper, it's on the AED website, just showing that most of these unconventional reservoirs aren't really reactive at all. So with that, it means a lot of times when we think water-based, going from oil-based mud to water-based mud, we think of reactive clays and that sort of thing. You don't have those, so we're not that concerned about that. We're at normal temperature, so below 250 degrees or so, just by way of additives change, that sort of things, we get to higher temperatures. And so in general, when we're thinking about going from oil-based mud to water-based mud, torque is probably our biggest concern. It's not some sort of interaction with the formation necessarily. It's, can I get the weight on bit that I need to drill fast enough to make a lower cost per barrel water-based mud more lower cost for the efficiency of the entire well. So that's sort of the framework around where this discussion is kind of headed, I guess.
Yeah, that makes sense. So let's start talking about the fluid itself. Talk about what a clear fluid is and why we would select that.
Yeah, so I mean, first and foremost, when we talk water-based mud, the question is, okay, well, what kind, right? And so drilling with clear fluids, we have a fairly recent tech tip on dilational hardening, which is why high spurt loss clear fluids tend to drill faster, especially at, the deeper you go. But it is, in effect, just a clear brine. So we're not putting a bunch of other additives in the mud. We're not adding weight material. This is something that, in particular, in the Permian Basin, you have lots of access to cheap brine, sodium chloride, so you can go up to about 10 pounds per gallon. And anywhere you can do that, it is just clear fluid and some corrosion inhibitors and a lube. And so that is, a big draw. However, you do have some density limitations. You have to go to other brines that can get more expensive to run. And then, of course, there's always well, what about produced water? And we've talked about how produced water can be quite problematic because it can, there can be other ions in there that can sort of gum up compatibility issues with lubricants and that kind of thing. But, that's where we're starting with is trying to draw the distinction of water-based mud, clear fluid versus, like a polymer system.
Right.
And, I put in here solids. The thing it's worth keeping in mind is you have a clear fluid that you're drilling with, but over time it's going to get solids in it.
Mm-hmm.
And so a lot of people are like, oh, clear fluid, solids should just settle right out, and I don't really need to be aggressive on my solids control. And all of those solids that you start to accumulate can actually create problems because they can actually lower your ROP. So you want to keep an eye on those. You want to make sure you're diluting. You want to make sure that maybe you have a flocculating polymer, you're centrifuging, you're stripping all that stuff out. So we're left with brine and lube, right? And how you're going to add that lubricant, because we mentioned torque is the primary issue. Couple of things to think about. One is depletion. You have to continue to add lubricant. You're going to lose some to the solids. These things want to stick to things, including cuttings. The other thing is, we've been doing a lot where we've encouraged people to look at the EDR data, look at mechanical specific energy trends, look at some of these other things where the rig can basically be your lubricity meter and tell you if you're short or if you need to add more, or when you add a little more and nothing happens, that, that's not the problem.
Or subjective comments from folks on location can be a somewhat of a lubricity meter. And funny,
but only if they're nice.
Exactly, yeah. No, but you'd be surprised. A lot of people, it's a lot of times when you're asking how it's performing, and you just get overall good, and because some sort of interesting opinion about it. But nonetheless, if looking at the correct data, assuming the operator will allow you to dive in and look at this kind of stuff, can really, is your best gauge.
Yeah, it's what's really captivating is that you can see when you add a lubricant how the rig responds, and then you're creating value. Like the product did what it was supposed to do. And we've talked about in the past, sometimes, we added some and then it stopped working. I was like, well, what did you just pump a sweep and watch it go around, or is it a product that just doesn't really stick around for very long? Like we can get to the bottom of that. So
yeah,
I think keep that in mind. I think the other one with clear fluids is, we tend to get lazy, right? Like I don't have to check viscosity. I don't have to do some of these other, it's brine, but that can be a trap in and of itself. Particularly people stop checking their alkalinities. And what we find is a lot of times it's like, oh, well, shoot, I'll just keep hammering it with soda ash. And then you create a carbonates problem. You cause cheesing or other issues with the lubricant because you're not staying on top of maintaining your alkalinities and keeping them balanced. It can cause foaming. It can create other issues that it's not the lubricant product, it's the environment at which it's being run that is manageable if you stay on top of it, but it's just like, oh, well, I don't really have to run too much of a mud check because nobody cares about some of these properties. It's like, well, don't forget them all.
Right.
And then the last thing I will add, going back to some of those cations and that sort of thing, is you're going to have these corrosion inhibitors, and don't forget about those either. Particularly, I've seen, there's always that temptation to run your calcium really high, or, who cares, right? Well, a lot of the corrosion inhibitor chemistry, in particular, oxygen scavengers, but some scale inhibitors, that sort of thing, they're supposed to bind up with calcium. And so by letting it run high, you're actually, by not treating it out, you're actually depleting it. So now you've got, when you talk about like pipe life and those sort of issues, you run the risk of neutralizing chemistry that's designed to help you
Right.
while you're drilling. And so there are calcium tolerant additives for corrosion packages. That's what our brethren to the north do. And, when they drill with calcium chloride, but those additives tend to cost a little bit more money. They require, a bit more monitoring. And so in light of that, most people would shy away from it and just keep the calcium down. So just something to keep, and that's true for polymeric fluids as well. But I think we tend to behave better because polymers and other things sort of get gummed up if you don't watch all your mud properties.
For sure. I do want to kind of track back a little bit. You mentioned about lubricants and obviously monitoring torque and drag and stuff. And when it comes to, can you help answer the question? Because I've heard the sort of the debate and the argument, but if you're running a lubricant, should you be able to see it when you burn a retort in your retort?
You might be able to see part of it. I think that's the challenge is one, if you're running a couple of percent or whatever, looking at that on a retort, like, is that 1.5% or 2%, right? Like within the margin of error of a J tube, it's pretty tough to call, especially when you're trying to look at the bottom of a meniscus of a very thin, the meniscus may dip down basically to look at 0 at the bottom.
No.
And you have a little bit on the edges. So, you can kind of trend things, but the problem is lubricants, not all lubricants are 100% one thing. Some of them are multiple things. And so some of it may show up in the oil phase. If you have some oil in there, some of it may be fully soluble in water, and so it just shows up in brine. Some of it may get cooked off because it's got more volatile compounds than everything else in there.
Got it.
So it's not a great way to do it.
Okay. Because sometimes you hear comments and it's like, oh, we've got this percent and here's what's showing up in the retort. And I just really wanted to add that question so folks to be aware and understand what you're running and some of the, I guess, things that if you are trying to, because obviously you're maintaining and the reason I bring that up is because when you're running a water-based mud, especially in unconventionals, lubricant is like a big topic, right? It's really the where the rubber hits the road and the benefit. So measuring concentration and figuring out how much you actually have in the system is not as just simple as just burning a retort. So
no, and I mean, you go back to the story of depletion, and the other part of it is, looking at your EDR data. If I add more, does the drilling system improve? If performance gets better, you need more. If nothing happens, you probably don't need to add any more. It's not going to make any difference.
right.
So I think we have access to more data that should help us. And I think at the end of the day, you can go back and run the numbers on consumption and try and come to terms with where you're at. Whether that, but in real time, a lot of people are just kicking and screaming to get the best they can. And if it ends up being 4%, you thought you only needed 2%. Review your KPIs and say, look, this product isn't,
Sure.
economics are different than what I thought.
Yeah, no, it's a good point. So moving on from the clear fluid side of things, let's talk about polymer fluid, because just like you said, a water-based mud can mean a lot of different things. And so a lot of times we will run a polymer fluid for specific reasons, Matt. And so, please unpack that.
So, I mean, a lot of these are mainly, pack, some xanthan gum. The advantage you have is you can weight it up. It's viscosified, so you can add barite for density. But that also means you're adding solids. So you got to keep that in mind. And the other thing is that when you're adding solids, you tend to require more lubricant in general. And so what that means is you may be doing really well at 2% in a clear fluid, and it takes 5% by volume to even see anything with that same lubricant. Because what it's doing is it's sticking to all those solids before it runs out of mud solids to stick to, and then it starts sticking to pipe.
Right.
So you've got some like competing interests there, which can accelerate depletion. However, the other thing I'll point out is you may want a totally different lubricant. The thing that worked in your clear fluid might not be the best for your polymeric mud. And so you may want to pick a product that's designed specifically for that. And I think, you know, you may want to check it with everything. I've seen, folks want to add some supplements that actually neutralize the lubricant or create other issues. So just make sure you're not shooting yourself in the foot.
That's a good point.
And look, I mean, I've seen people run polymeric fluids and, throw some beads in there. I think, there can be a time and a place for that. But then you get into, like we've talked about in other episodes, who's going to run the unit? How good a separation am I going to get, to recover them? Those kinds of things. So it gets complicated, but it may be a supplement that is helpful, especially if you're weighted up. Sure. For a mudded up system. They're certainly not my favorite. And I think depending on who shouts the loudest, you could go either way on the ups and downs of those things. But it comes into conversation because a lot of times, a polymer, especially, there are studies that show that polymers do provide some good lubricity on their own. And then with a lubricant, they can do even better, perhaps, depending on the chemistry of that lubricant. But if it doesn't get you there, and then, you may be looking at beads or what have you. Sure. But you have a more complex mixture too, right? And so we don't want to overlook that all these other things you have in the mud are interacting with that lubricant, which can create more challenges to make sure that you have good compatibility and that it may be fully compatible, but you may run the issue of looking around and realizing like, hey, my lubricant actually doesn't do very much. Like the lab data looked really good, but once I put it on this rig circumstances, I'm not seeing the reduction I expected. So just trying to make sure account for all those variables up front.
Gotcha. Assuming we make it to TD and we've added, all the products that we needed to get there, obviously got to run casing, which, in some cases I've heard, I haven't seen it done down here a lot, but in other basins, a lot of times they'll even displace to something more lubricious, i.e. oil-based mud to run casing. But assuming you're going to run casing with water-based mud in the hole, what are some considerations there and some suggestions on that front?
Well, I think when you've got a small volume, take advantage of how little cost it would be to spot across your open hole at least a fresh lube pill, 4% or whatever lubricant, keeping in mind that you are about to introduce a bunch of fresh, untreated steel into this wellbore. So have enough lubricant to stick to all those new shiny surfaces. Well, they're never shiny, right? But knowing also that your casing can be a bit stiff too. So, if you've just got to do like a 90 barrel pill or something like that, 4% by volume, we're not talking about a ton of lubricant as insurance to help you get that stuff down. And that's one of those, if you know you can get away with it, don't add it. If you want a little insurance, the cost is relatively inexpensive, but you can also pare it back and say, well, did that make any difference or not? Yeah, however, we do have some customers who've said, yeah, it works really great to put in, spot something that's got a little more lubricant fresh before we come out of the hole, and so that when we come in with casing, it gets treated. So I would just say that it's a relatively low cost way to help with getting that casing down.
Yeah, most definitely. So Matt, besides the operations piece and running the mud itself, kind of taking a step back and looking at the sort of the drilling process as a whole, and some of the unintended consequences with using water-based mud. Let's talk about that, because that's a piece of it that really could make a huge impact on the economics of a well over time.
Absolutely. I mean, I remember this was, a few years ago, we had a customer that said, we're just going to use water-based mud from now on. And it worked pretty well. And then they released the rig and all of the pipe got rejected. So it was like, hey, we're saving this money. And then it was like, oh, actually we owe like $1 million for, for pipe that all got DBR'd.
Mm-hmm.
And so I think pipe life requires some special attention. And with this, I think monitoring your torque, trying to keep lower overall sustained torque while you're drilling, Um, and I mean, look, think about your hole size, right? Like smaller pipe is going to buckle more. It's going to get beat up more. Um, is this something maybe you start out with where you can use 5.5 inch pipe and 8.5 inch hole and not, you know, not on the skinny pipe? Um, are those some things to just keep an eye on, to make sure that you don't have this sort of bill come due?
Yeah.
And I think more frequent pipe inspections, at least until you have an idea of how things are going. But hammering this stuff down or like being aggressive is kind of the way of the oil field. Even if you're like, all right, guys, we're gonna take it easy. It's hard to get somebody to do that on the rig floor. So just understand the physics of this. You're going to likely have higher sustained torque, but with proper treatment, you can get it down. We've seen it. We've done it.
Right.
But if you're whatever, we'll worry about it later. That bill will come due.
Right. Pay them now or pay them later, but
Yeah.
eventually you're gonna have to pay for something.
Yeah. So monitoring your pipe early on, I think, is an important thing to start out with, and making sure you've got the right approach in place. And then, the other part of it is just depending on what you're running, picking the right lubricant. So, um, what we find generally is most people are really happy in the clear fluid domain. That works. We drill fast. It's cheap. That stuff that stuff works pretty well. When we get into the systems where we're weighted up, it gets a bit more complicated. And so, I guess the success is not as glaring per se. You're also in probably a more challenging area because you actually need mud weight. Those kinds of things. So, you may need to optimize your lubricant. And so there may be better applications than others. It may be that you just come to terms with you need more of this to achieve the same thing you did in clear fluid. And so all of that, I think, is a really important thing to sort of go through the exercises, wrap your head around it, um, and think about what concerns you the most. But a lot of this stuff you can plan for. You can do some of it in the lab. And then I think the other part of it is having a good plan at the rig and saying, okay, based upon what I'm seeing, this is the move I'm going to make.
Right. No, that's a good point. And something else to consider too is operationally, if you're on a rig that's going from traditionally oil-based mud to water-based mud, there's some things to be aware of. And then obviously at the shaker, sometimes you can have some issues with regards to stuff sticking to the shakers. But again, if you've been doing it for a while, you know about it. But you automatically think, oh, water-based mud, we need to have a water pressure washer. A diesel pressure washer actually works really well at the shakers because of obviously the affinity for metal, the lube, and the cuttings and kind of all the sort of the mixed up in there is going to could cause some issues at the shaker. So if you're someone that's like, oh yeah, our rig's actually doing this, talk to the company reps because that'll be something that'll relieve some headache. Tiny pro tip, but some people it kind of goes against traditional or your thinking of going from water or oil based to water based. But nonetheless, have you a diesel pressure washer at the shakers because that'll help too.
Yes.
That's all I got, Matt, for questions. Kind of a way to put a bow around it and tie it up. Any closing last words?
I mean, my big thing is, well, it's all about the lubricant, but it's more about measuring the lubricant at the rig, which I just don't think we do enough of.
Yeah, no, that's a
So-
good point. I guess I'm curious, Matt. Do you see water-based mud or lubricant technology getting to a point where taking cost out of it? Is there some interesting things coming down the pipeline that you know of, or interesting chemistry? Just because everyone is going, okay, 2 mile laterals, whoop-de-doo, we've done it. 3 now seems to be, nobody's concerned. 4 miles gets a little dicey. If the trend continues, we could be going further than that, and naturally people are going to want to stick with water-based mud. So, are you and your team thinking of anything sort of beyond where we're at now, or?
Yeah, I mean, it's kind of interesting because it requires a mindset shift. Because the answer, if it's can I pay the same price per gallon and get this, that, and the other, it's probably no. But as we're able to use better data sets to show the difference some of this stuff is making,
Mm-hmm.
then yes, we're finding that we're able to come up with more robust chemistry specifically for higher torque conditions. We're able to sort of tweak some things in a way that I think had been sort of overlooked. And so that's really helping us sort of get a way forward, but it wasn't going to happen at, $5 a gallon or, it just, and so but I think the fact that it's easier to demonstrate where the value is coming from
Makes
has
sense.
very much helped with those challenges. I think that could help reorient people's mindsets, and then we have more things to play with that we know we're promising, just not economic.
Sure.
Um,
Okay.
so yeah, I think there's a lot in the pipeline. I can't go into too much detail on some of that stuff, but we're looking at other ways to measure these things. A lot of lubricity meters are just calibrated to water, and a really good lubricant is about, might start showing you measurements that's 10% of that coefficient of friction reading. And at that point, you're just within error. Like, they all look about the same at that point. So we're adding some precision, or we're hoping to add some precision and think things through a little bit more specifically to what we do. And
Cool.
You
That's
know,
good. Always
yeah.
on the cutting edge, Matt. It's
well,
wild.
something like that.
Awesome. Well, folks, again, if you have any further questions, you'd like to dive into anything we talked about today any further, hit us up on LinkedIn, or you can reach us at the Flowline podcast at aesfluids.com. Or if you just have another episode idea, please reach out. Again, some of the best episodes come from listener questions. And with that being said, everyone, appreciate the support. Check us out on YouTube as well. Tech tips, lots of great content there. Connect with us on LinkedIn, especially the AES page that continues to grow, and just some great things being put online for all the folks to educate themselves even further in the mud world. And with that being said, everyone, we'll see you next time. Thanks.
Take care.
Thanks for listening. Please tune in next week for another exciting episode of the Flowline. And remember, may your returns always be full and your trips always smooth. Views expressed in this program belong to participants and not their employees. The program is for informational purposes only and cannot take the place of seeking professional advice. Copyright AES Drilling Fluids.